What if I told you that scientists recently discovered something so massive it shouldn't even exist according to our laws of physics? A structure so vast that light, traveling at 300,000 kilometers per second, would take 15 billion years to cross it. This discovery is forcing us to question everything we thought we knew about our universe. To grasp the immensity of our universe, we must first establish a sense of scale, beginning with what's familiar before venturing into the truly incomprehensible. Our journey starts here, on Earth, our cosmic home. This pale blue dot, suspended in a sunbeam, is where everyone you've ever known has lived. Every human story has unfolded on this tiny sphere, approximately 12,742 kilometers in diameter. But Earth is merely the first step on our cosmic voyage. Let's expand our perspective. Light, the fastest entity in the universe, travels at an astonishing 300,000 kilometers per second. At this incredible speed, light can circle our planet nearly 7.5 times in just 1 second. Yet this same light takes 1.28 seconds to reach our moon, a distance of about 384,400 kilometers. To put this into perspective, if you were to board an airplane cruising at 1,000 kilometers per hour, it would take you approximately 16 days of continuous travel to reach the lunar surface. But the moon is practically our next-door neighbor in cosmic terms. Let's venture further. Mars, the red planet that has captured our imagination as a potential second home, stands about 56 million kilometers away at its closest approach to Earth. That same airplane would require 6.2 years of continuous flight to reach its destination. Now, let's consider our Sun, the star that gives us life. The average distance between Earth and the Sun is approximately 150 million kilometers, a measure known as 1 astronomical unit. At this vast distance, sunlight takes about 8 minutes and 20 seconds to reach us. Venturing to the edge of our solar system, we encounter Neptune, the most distant planet from the Sun, situated an average of 4.5 billion kilometers away. That's 30 astronomical units. Sunlight takes 4 hours to journey from the Sun to Neptune. If we attempted to fly there at the speed of a commercial airplane, it would take a staggering 490 years to complete this interplanetary journey. Now, let me open a loop that we'll close later. What would happen if we could somehow instantly transport ourselves to the edge of our solar system? The answer will challenge everything you think you know about distance and time. Beyond Neptune lies the heliopause, the final known boundary between the heliosphere and interstellar space. Crossing this threshold, we transition from the familiarity of our solar system into the vastness of interstellar space, where distances stretch to truly staggering scales. Proxima Centauri, the star closest to our Sun, is located approximately 40 trillion kilometers away. This equates to nearly 270,000 astronomical units. Within this interstellar realm, the scales and distances involved dwarf everything within our solar system, challenging our understanding and imagination. Remember that loop I opened earlier? Here's where it closes. If you could instantly transport to the edge of our solar system, you'd still be less than 1% of the way to the nearest star. That's how vast the space between stars truly is. Within the Milky Way, the average distance between stars is about 316,205 astronomical units, illustrating the vastness of our galaxy. To comprehend such astronomical distances, consider stars like Betelgeuse, one of the largest known, with a diameter surpassing the orbits of Mars or even Jupiter around the Sun. Betelgeuse is nearly 700 times the size of our Sun, or about 1 billion kilometers in diameter, yet it appears as just a bright point in our night sky, despite being 650 light-years away. Our galactic home, the Milky Way, spans approximately 100,000 light-years across, but even our galaxy is just the beginning. Recent discoveries have revealed structures that dwarf even the Milky Way. The Hercules-Corona Borealis Great Wall, the largest known cosmic structure, is now estimated to span up to 15 billion light-years, significantly larger than previous estimates. This immense structure was identified through the clustering of gamma-ray bursts, which serve as markers for the distribution of galaxies across vast distances. Its size far exceeds the theoretical limit of about 1.2 billion light-years set by the cosmological principle, which states that the universe should appear homogeneous and isotropic on large scales. The existence of such a structure challenges current cosmological models and may require revisions to our understanding of how matter is distributed in the universe. As we reach the limits of what we can observe and measure, We find ourselves at the frontier of human knowledge. The universe, in its vastness and complexity, continues to surprise and humble us. Every new discovery seems to reveal how much more there is to learn.